Hi, this lesson continues on from where we left off last time, when we were looking at the events surrounding the 1980 eruption of Mount St Helens. What I want to do this time is put Mount St Helens and the risk that it poses into a regional context. You can see from this map that Mount St Helens is part of a chain of mountains called the Cascade Range. This is in the far northwest of the US. There's a whole chain here of big dormant volcanoes. There is an active subduction zone underneath this area where a small oceanic plate called the Juan de Fuca plate is being subducted under a continental North American plate. This creates a whole series of volcanic hazards. Just to put this into some sort of context, if we look at the area surrounding these volcanoes, we can see that there's a number of really some very large cities spread along the seaward side of these volcanoes. And the whole area of the map that you're looking at has a population comfortably in excess of 15 million people. So there's a significant risk posed by active volcanoes in this area. Now, one of the ways we can assess that risk is by looking at the frequency of events. This is a list of the volcanoes in the Cascade Range that have erupted during the... You have this diagram on page 13 of your theme booklets. Each of these volcano symbols on the diagram represents an eruption in time. So we can see how often each of these volcanoes has erupted. For example, Mount Adams has erupted twice. So, what I want us to do is I want us to use this data to try and work out what we call the recurrence interval. How often it is, on average, between each of the eruptions in this range. So, what I'd like you to do now is press pause and have a go at the questions on page 13 of your theme-mate booklets. Okay, let's have a look at some answers to this. I've already given you the calculation there for Mount St Helens. We're looking at a 4,000 year period. If we count the number of eruptions for Mount St Helens over that time, it's 19. And simply dividing the duration, that 4,000 years, by the number of eruptions, 19, we get an average of about just over 210 years between each eruption. If we look at the other four volcanoes I asked you to focus on, Mount Rainier has a recurrence interval of 363.6 years. If we look at the other four volcanoes here, Mount Rainier has a recurrence interval of about 363.6 years. Glacier Peak has a recurrence interval of 666.7 years. Mount Baker, just once, in 4,000 years. And finally, their Lassen peak, which has a recurrence interval of 1,333.3 years. Now, you may be wondering why I've picked those 5 volcanoes. Those 5 volcanoes are the ones that the USGS have ranked to be the most dangerous. Have a go at the digging deeper activity. To what extent do you agree with that rank order, where Mount Rainier poses the highest risk, and of those, Lassen Peak, the lowest risk? Do you think those volcanoes should be on that list? Do you think there are some, perhaps within this range, that pose a greater risk? Would you put them in the same order, and why? Write your ideas down on a sticky note and put them on page 13. Okay. We can see from this a recurrence interval does give us a rough idea, perhaps, of how dangerous a volcano is. However, it's a very crude measurement. You can see from the diagram that these volcanoes don't operate on a timetable like a bus. There are phases of activity followed by phases of dormancy. Also, we need to think about what type of eruption could occur and also what's around the volcano to try and assess the risk that these volcanoes pose. Next time, we're going to have a look at another way of trying to quantify the risk posed by a volcano.